All right, we're going to introduce you to scientific notation and look at a few examples of numbers that are in scientific notation. So in scientific notation, your first number will have a digit between 1 and 9 in front of the decimal, and then all other digits behind the decimal. You won't have a 0 here. It will be a number between 1 and 9. The second part of scientific notation is this power of 10, either a positive exponent or a negative exponent. I'm going to put a few examples here, and then we'll talk about how to write them in ordinary notation. There's some good examples. So when I have a number 5.6 times 10 to the second power, that 10 to the second power actually moves the decimal over 2 places. Now if there's a 6 here, I have to fill in a 0 for that number to be correct. So the answer would be 560 in ordinary notation. Now I talked about moving the decimal, but I did leave the decimal off on this side. One of the nice things about scientific notation is that the number of significant digits over here matches the number of significant digits on this side. If I had added a decimal, then the 0 would have been considered a significant digit also, and I don't want to do that. Okay, so let's see what happens with it's a negative power. A negative power, instead of making the number get larger from 5.6 to 560, is going to make the number get smaller. So again, it's going to be moving a decimal 2 places, but the decimal is going to get, or the number is going to get smaller, so the decimal will go in this direction. And again, we'll have to fill in a 0. This time the decimal is important. It's decimal point 056. And again, the 2 significant digits here, and there's 2 significant digits there. So here's another example with a negative exponent. So I need this number to get very, very small by a power of 8 that will be dividing backwards. So 1, 2, 3, 4, 5, 6, 7, 8. And we have to fill in zeros for all of those places. So let's count that. 1, 2, 3, 4, 5, 6, 7 zeros. And then the number 3, 4, 2. And again, let's count significant digits one more time. 3.42 clearly has 3 significant digits. All of those zeros we don't count, and this number has 3 significant digits. Now, 7 doesn't have a decimal point on it, but whenever we have a number without a decimal point, we just assume that the decimal goes right behind it. Now this is times 10 to the 5th, so the number's going to get larger. We'll move it 1, 2, 3, 4, 5 places in this direction. And we have to fill in 5 zeros then. And again, there I don't want to add a decimal point because I only want the 7 to be considered a significant digit. With large numbers, I often put the comma in so it's easier to read the number. 3.70. And we want the number to get smaller, 10 to the negative fifth, so it'll get backwards. 5 places, so 4 zeros. And then 370. Now 3.70 is a number that has 3 significant digits. This 0 behind a decimal is considered a significant digit, and so you do want to include the 0 over there to count that as a significant digit as well. And our last example. This is times 10 to the 6th power, so we want the number to get larger, so I'll count in this direction. And I'm going to need to fill in with 1, 2, 3, 4 more zeros. So 370 and then 4 more zeros. And I can put some commas in. Now this number looks like it has 2 significant digits. The 3 and the 7. But my original number had 3 significant digits. So this is that place where we now need to put a bar over that 0 so that that counts as a significant digit as well. It's much easier in scientific notation to show that this number has 3 significant digits than it is in our ordinary notation. All right, now I think we're ready to go the other direction. So we'll clear this. And we'll take some numbers and then that are in ordinary notation and write them in scientific notation. There we go. All right, so for the first number, we want to write the first part of our scientific notation number with the 9 first, then the decimal point, and then all the other digits. So we moved the decimal point 1 place. Now 0.912 is a smaller number than 9, so we would have to multiply the 9 times 10 to a negative exponent, and we only moved it 1 place, so it's 10 to the negative first. All right. In this number, we want to put the 4 first, 1 significant digit, then the decimal point, so in this number, we move the decimal point 1 in this direction. Now 48 is a bigger number than 4.8, so to make them equal we have to multiply by 10 to the first power, a positive 1. So small numbers will have a negative power on 10, and large numbers will have a positive power on 10 when we rewrite them. Okay, here I have to move the decimal all the way to the other side of the 7. Now you can write the decimal or you can decide not to, like we did on that other example. And now we had to move the decimal 1, 2, 3, 4, 5 places to get it there. That's a very small number, so it's 10 to the negative fifth. Here we need to move the decimal right behind the 2. And here's a place where those significant digits count. So we want to include that 0 when we write it in scientific notation, since all 3 of those would be counted as significant digits. And the decimal moved 3 places, and that's a very small number, so it's a negative third power. Here we want the decimal between the 5 and the 4. And we have to count the decimal that would have been here. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be 5.4 to the 9th power. You can definitely see with examples like this where scientific notation is much easier than writing the ordinary number out for very large numbers.